Okay, I have another little activity for us here. It's for graphing systems of equations. So we can also find solutions to systems of equations by graphing. What you're going to need to do this activity is you're going to need a piece of graph paper and you're going to need a pencil. You're also going to need to make sure that you stay along with me and you follow along, pause the video when you need to so that you can graph it and stay up with me. So here we go. Here's our first two equations, y equals negative x plus 3 and y equals x plus 1. They are already in the correct format of y equals mx plus b so that you get the slope and the y-intercept. So let's graph that top one first. So pause the video and graph that top one first. Welcome back. This is what it should look like. It's going downhill and it's crossing at positive 3. Okay, let's get ready to graph the bottom equation, y equals x plus 1. Pause the video. Welcome back. Here you go. Once you graph that other one, it's going to be going upwards with a slope of 1 and crossing at positive 1. And we see that point right there where they cross, right here in the middle, and we find out what that solution is. And the solution is 1, 2. That is the solution of this system. Let's practice this a few more times. Here we have two equations, y equals x plus 9 and y equals negative 5, 6x plus 9. Graph the top equation. Okay, once you have it graphed, it should look something like this, going uphill and crossing at 9. Go ahead and graph the bottom equation. Once you graph it, it looks like this. We can kind of see where they're crossing right there. Write down what is that ordered pair right up here. What ordered pair is that? And you're correct if you said 0, 9. Let's take a look at another two equations. The first one, y equals x plus 5, is in the correct format. The bottom one, 4x plus y equals 10, is not. Rearrange it so that it is in the form of y equals mx plus b. Remember to pause the video so that you can find the answers after you've done the work. Welcome back. Here's the rearrangement of this equation to y equals negative 4x plus 10. Now they're both in slope-intercept form. Let's go ahead and graph that top equation, y equals x plus 5. This is what you would have gotten when you've graphed it. Go ahead and graph the bottom equation, y equals negative 4x plus 10. And when you graph it, you will be getting this. And again, you're going to look for where they are crossing. They're crossing right here. Please record what that point is. And that point is 1, 6. Let's take a look at another equation. I have two more for you. Here we have 2x minus 3y equals 9 and x equals negative 3. That first equation is not in slope-intercept form. Let's rearrange it so that it is. Welcome back. Here's what that looks like rearranged. You end up with y equals 2/3 x minus 3. And then go ahead and graph that equation. Here is that equation. It is going uphill, rise of 2, run of 3, and it is crossing at negative 3. Let's take a look at that second equation, x equals negative 3. There is no y here, which means this will not be touching the y-axis. This does not have a y-intercept. That means it does not have a slope either. So think about what doesn't have a slope, will not touch the y-axis, but touches the x-axis at negative 3. And go ahead and graph that. Hopefully you came up with this line right here, this blue line. And what we want to do again is look right here at this point. And what point is it that they are crossing? Hopefully you've come up with a point, negative 3, negative 5. I have one more for you where we're going to do a lot of rearranging. We have 3x plus 2y equals 10 and 3x minus 2y equals 14. Let's take a look at that first one. Neither equation's in the correct format of slope-intercept form, where y equals mx plus b, where m is the slope and b is the y-intercept. So let's rearrange that top one first. And when you rearrange it, you end up with y equals negative 3/2 x plus 5. Go ahead and rearrange the bottom one. Remember to watch your inverse operations. Once you've done rearranging that, you'll come up with y equals 3 over 2x minus 7. Let's go back to that first equation, y equals negative 3 halves x plus 5, and let's put it on the graph. Here you would have had a line going downhill, down 3 and to the right 2, and it's going to cross that y-axis at positive 5. Let's go ahead and graph that second line, y equals 3 over 2x minus 7. Once you graph that one, it's going to be going uphill, positive 3 and to the right 2, and then that one's going to cross at negative 7. We can see where they're crossing right here. What is that ordered pair? The ordered pair is 4, negative 1. Hopefully you've had some practice here on graphing a system of equations.